All right. Good morning, everyone. So hopefully everyone's having a good time. We are having a good time here in Dhaka.
Hello, hello, hello.
So good morning again and welcome to the Disaster Mitigation Working Group session here at APAN61. So by the way, I'm Franz De Leon. I'm from the Department or Ministry of Science and Technology Philippines. So this session is co-chaired with Dr. Eric Yen of Academia Sinica Taiwan and Dr. Virchai Tanpipat of Hydro Informatics Institute, Thailand. So this group, the DMWG, aims to build up capacity of hazard risk analysis by case studies based on deeper understanding approach. So for today, we have a great lineup of speakers. We actually have 8, I think one of the most in any DMWG session. So we'll try to keep up with the time. So without further ado, Chai, would you like to say anything?
Absolutely, yes. Welcome, and then we also looking for the collaboration, and we can talk and how we can help, especially disaster, typhoon, flooding. Philippines knows a lot, tsunami, the weather, typhoon monitoring, and then how to handle. Now we think about that. We talked before how to handle after the disaster happened, because we're usually talking about like before or during, but now we need to talk about after also and try to get the more collaboration, support and help. And now, I don't know, Filsa having any talk? Bani will talk, okay, that there's a Copernicus program that get more detail from Bani that you can use the satellite from Sentinel satellite from Copernicus program. Welcome. Thank you very much for coming. I have a mic. Over to you.
Morning, everyone. Eric Yan from Academia Sinica Grid Computing Center in Taiwan. I'd like to highlight one of the key points of this working group, that's collaboration. Yeah, some updates. It's my honor to be the first speaker in the working group meeting, as always. Yeah, it's very important and it should be natural to make use of the AI, supporting the hazard risk analysis or to minimize the loss from the hazards. But now the feasible approach might be to combining the scientific computing, AI technology, and also the application. Application means domain specific and also user oriented. That means what are the problems we are going to solve? For example, the weather prediction, hazard risk analysis on specific type of hazards. Actually, the working group has been started from 2014, if my memory is corrected. Been more than 10 years. In the past decades, we've been working with domain scientists based on the physics-based numerical simulation. As most of you are aware, that's the one of the primary approach to understand the science behind the hazard and to generate the effective numerical simulation for understanding the risk, for understanding the science, the root cause of the hazards. Because the condition of each hazard is different, so it's necessary to understand the root cause. And the purpose is to improve the capability of prediction in the future, and also to support the similar hazard in different places. So domain knowledge is always the foundation, even in the AI era today, because of the reliability, accuracy, and also explainability of the simulation process, the analysis workflow. And it's of course very important to have the data to have all the required data from different sources. That's also involve another key points, the open and sharing data. There's a new working group leading by Dr. Verchai here. And we have to have a research infrastructure, computing infrastructure, or collaboration infrastructure to supporting all these activities, and to facilitate the advancement of all the technology and sciences in different domains. So one of the approach we've been experimenting or conducting in the past decades is case study. We collect use cases from the partners. For example, the tsunami case or typhoon in Taiwan or in Thailand, in Philippines, or the volcano cases in Indonesia, for example. And then we have the domain scientists working together with the local scientists and to collect data to understand the event and try to dig deeper into this event. And one of the outcome is a numerical simulation tools, so that the case could be reproducible. The simulation could be applied to the future events in different places in the future. And also, it's very common today to be used for other societal impact analysis purposes, for example, the sustainable development goals. So again, without open data, it's not possible. In Europe, they are focusing one step ahead. They call it open science. That means to federate all the resources as I mentioned in the first item together. So we are also trying to build up this mechanism for collaboration using a similar approach, open science, as what has been implemented in Europe. We hope that the outcome could be directly applicable for our partners. And we hope that scientists could help us to get insights about the future opportunity and also to improve the capability to reduce the hazards. So one key point from today to the future is learn how to make use of the AI. I have some examples in the following slides, which is part of the proposal we like to get funding support from the Asia Connect last year. We hope we could still have opportunity to discuss maybe today or in the future APAN meetings about the potential of collaboration opportunities. The last thing is that what I learned, the similar idea from a recent publication in Nature. That's about the chemical synthesis using AI technologies. Let's how to get the take advantage of the collective intelligence for AI-assisted discovery. So we could start it from a computational framework, as I mentioned, to integrate the domain scientists, the users, and also the computing infrastructure. That enable the scientists to support for the generation of the collective knowledge, focusing on the disaster mitigation. So that's the long-term goal. This is a summary of the use case strategy and also some of the use cases we've been conducted in the past 10 years. As I mentioned from the case study first, so that's assigned by the partners. And now we have some domain experts, as I mentioned. They are scientists about tsunami, about the weather, about the air pollution, about the extreme weather and the flooding, volcano, and also forest fire. Yeah. Yeah. So we try to, after we finish some of the case study, we try to make all the finished case study open, to make the simulation tools available, to make the case study reproducible. Yeah. And then we also welcome new case studies. The other thing is that how to integrate the AI tools together. So that's the probably the work list for the future. So one of the example about the storm surge and extreme weather is here. That's a typhoon case in Thailand. That's a rare case. Typhoon goes from the South China Sea to the Andaman Sea, and the storm per book. So we have scientists generate the simulation and comparing to the observation data, as mentioned here. So about the extreme weather, it's very important to understand the interaction of the ocean and land, of course, and also the atmosphere. So that's what I mentioned about the science behind the hazard. And this is the case study about air pollution. Again, 10 years ago, we have scientists, they are working on understanding the transportation mechanism. That's a very, very long way, more than 1,000 kilometers from Southeast Asia to the Northwest Asia. What are the mechanisms in different seasons? And then now they are making use of the AI to improve the pattern recognition and also the summarization from the different cases they collected in different attitude. So this is the collaboration framework I just mentioned. The other thing is that satellite images are very, very useful tools for the analysis of the hazard risk to get the data which is not possible from the ground station. Yeah, and also it's there are still a lot of potential to get insights from those data collected from the satellite. Actually, two things. One is the improvement of the data structure. There is a open data cube system, which is making use of the geospatial data in layered architecture. For example, the vegetation could be one of the layers. The DEM could be another layer, etc. The other key point here is that the data in this data structure, they are analysis ready, which means that makes the application of the satellite data more easier. You don't need to do georeferencing, geocorrection, and also, for example, the cloud removal. Those pre-processing has been done in this data architecture, and everyone could make use of those data directly. So the cost reduction has been made. That's just one example. Another thing that it's easier to federate the data in different time zone, in different time. Yeah. So to integrate the geospatial data, the temporal data, and also the attribute data together. For example, you can understand the impact of some hazards. From the beginning of the hazard happens to years after, including the recovery from the hazards, the situations. Yeah. So that's just one example. So in Taiwan, we are working together with the space agency in Taiwan, and a production open data cube system has been operational, supporting the applications in Taiwan and also other partner countries such as Thailand and other Southern American countries, for example. Another important collaboration in Asia is Sentinel Asia. That means the satellite data is open to Asia partners. Whenever there is any disaster or hazard happened, you can make a request to these systems, and all the partners, all the space agencies in different countries could help. They are very happy to provide their satellite resources to support, to share with the requester. In most of the cases, you could get the images in less than 1 day or no more than 2 days. Yeah. So here's the statistics. This one is by year, the request, and you can see the distribution in different months. The table over there, that's the summary by the Sentinel Asia in 2024. So during 2027 and 2024, the request number in different type of hazards, and also more than 90% the request has been fulfilled. And this is the idea how the system is working. So once there this disaster happened, you can make requests to the system, and there is some validation approval mechanism inside, and then will be this request will be shared to all the data provider node and also data analysis node. Almost every space agency who have the satellite running, they are part of the collaboration already. They are very happy to support the any hazards bring by the disaster. The vision is that the Sentinel Asia, the vision is that to support the life cycle of the disaster management from the pre-disaster to the recovery. Yeah. So the services are keep improving based on the real cases, based on the requests from the partners. So this is another statistics in the distribution of the country making the request. Yeah. Again, from 2007 to 2025. Yeah. So that's a very good model for the collaboration. Now it's based on the satellite images, not just the image itself. Now many countries, they also provide the analyzed data. This is one way. Yeah. So you can see some details. You can check all the requests and what are the shared data sets from the Sentinel Asia website. Using the keyword Sentinel Asia in Google, then you can see the website. All the cases could be checked. VAP, that's a value-added provider. So many sites, they are now providing some kind of insight data to support the hazard reduction or disaster management. So here are different cases in 2025. The other thing is that I reported in December, there's a online meeting about the open data in terms of the requirements from the disaster management. So in Taiwan, we've been trying to organize the sharing of the data collected or managed by the government-funded agency or the academic institutions. For example, here is the environmental data from the government environmental protection agency. The marine observation data that's managed by marine science centers. So at least now, users in Taiwan, we can access by the requirement with the different types of data sets. And now some of the guidelines and rules has been defined. So on the other way around, today, if we would like to facilitate the open data, it's very important from the government, from the data owner, from the management institute of the data to define the rules and guidelines how to access the data and try to make the data open and also to support the collaboration, at least for the disaster management and for the public services, etc. Fair principle, as you most of you already know. Here is that the fair principle is not just for the data, but also for the research software and also the computational workflow. Yeah, that's also applicable and also required to have similar mechanism to make the open data accessible and applicable. So based on the collected requirement from the use cases, from the users, from the partner sites, we hope to have a concept design at least of the collaboration infrastructure, including the computing services and resources, and also possible to federate the AI tools, and also to provide the data sharing under the FAIR principle. Yeah. So I think the next step is you are very welcome to promote any use cases, and we can try to find the scientists to work together. APAN, the working group, is a collaboration platform for these activities. So here are the schedules. And in between the APAN meetings, at least there is a ISGC conference, which has been running more than 20 years. And from 2006, we always have a environmental computing workshop, which is initiated by the Supercomputing Center in Munich, in Germany, together with us, AGC. So in this year, we have 4 sessions in IGC. Yeah. So Professor Verichai is also a speaker, and friends, Asti is very welcome to share your experiences as usual. Yeah. Please check the details of the whole conference. We also have the whole week security workshop. And here are lists of the keynote speakers, including the global internet from expert from ESNet, and also the last chair of the core data. Yeah. And also we have the computational seismology scientist sharing the experience, and of course the AI and quantum computing. Yeah. So just last slide. So thanks for the great support from different agencies and also the partners. Yeah, in the past 10 decades. Yeah, we hope the collaboration could keep going on. Thank you so much.
Thank you, Dr. Eric. So, any questions from the floor?
For open and sharing, we try to work close with the agriculture and disaster mitigation. And for APAN now, just last APAN, they have agreement, the MOU with the core data now. Well, not APAN, they have signed it in Australia in the International Data Week. Marcus signed. So now we are very close, and we agreed to have initiative with the Eric talk about that. He already mentioned it. Have a webinar, and Monday I asked Matty, and then probably the next one gonna be in March. But we have to schedule. Have to ask our friends also that who, when. So we don't know date yet. But the first time is like a little bit close, because we just want to introduce APAN and core data, but the second one should be open to everyone.
All right. Thank you, Chai. Any other question?
Uh, Thank you very much for your nice presentation. On a your slide, I have noticed that uh, you people sir try to include the fire, something like the surface fire. So could you please uh, make some comment like if the surface fire uh, is amplified by the wind, and then what is going to be happen, and how will you model those scenario in
Yeah.
supported by AI?
Okay. The model and the AI thing.
Yes, yes.
Well, don't go that far yet for the disaster. Like now, today, I'm just talking and looking. It's a very bad condition in the Victoria. I'm talking with Marcus and my friend there that the weather change is going up to 42 degrees, but the wind is okay. Yes, the wind is one of the factor for the fire behavior. It's a fuel, it's the weather, and it's the terrain.
Yeah,
Depend on the terrain.
Yeah.
And if you have different kind of fuel, different. When you do the model spread, the fire growth model, there are so many, but you need to calibrate them. Last year at the ISGC, one of the lady from, I don't know, manager or something of India or something, what is her name? From San Diego supercomputer. We tried to contact her, but she never replied. 2 times already, I think I gave up.
I see.
They run everything for fire behavior in the San Diego supercomputer, but the problem is they use very big data, like use LiDAR scan the
But-
field to add be as input. So right or wrong, it's really depend on the input. They're still using Ratomel
They don't
equation
use
from Canada. Oh no, yeah, from the US. Ratomel. And then everybody using that fire growth model, but it's really depend on how
They
good
use-
is your dam, how good is your input of the field, and the wind changing all the time. So it's so many factors.
Yes, I do. I do agree with all the factor that you have mentioned here is
Yes.
associated with the amplification of the fire. But if you would like to really predict the real scenario, then
Yes.
you have to
What is the data?
consider those
Yeah,
parameters.
yeah.
Otherwise,
It's,
it will be
Cal-
quite difficult. Yeah.
Cal-Fi doing it, but they still need the plane with thermal camera to go and scan. Still every day, 2 times. Now with the Australia,
Sorry.
they're doing a simulation as well. But when the wind chip is different, now I just try to talk with the Korean Forest Service. They also have it, the simulation like online, like you can use it online. The helicopter going, blah blah blah, but and make a plan when the fire moving. So I also try to
Yes, sir.
to get that.
I think that as I found here is like one of the assisting tool is the numerical simulation, but
Mhm.
numerical simulation is in other words like in adding with the supercomputing is very expensive, but
Mhm.
parametric study is quite easy once your model is established. So
Not
rather
very-
than
yeah, but
rather than
people
consider-
saying that, but if you want to do it more accurate, it's depends on accuracy. You can run it, the accuracy 50%, yeah, for fun, yes, but operation cannot. Operation need more than that. So always like TASA in Kazakhstan, I know the people there, you need to validate. Okay,
Yeah,
so
of course,
for the burn area, and then you
Of course.
adjust your equation the way you run it. But you really need the field to go to field data to go
And
to check.
yeah, in my understanding, as of today, maybe the equation that you have mentioned is well established.
Yeah, it's like 50,
Well established.
50,
And
60, no, it's too old already. But nobody
Yeah,
in the world can have a
Eh,
new one yet.
yeah,
So
yeah,
we have to
that
use
is impossible. But regarding the terms of the equation set that you have mentioned is well established now.
Yes.
You need to input like the new fuel system or new like
But the
surface area.
accuracy, see, yeah, like the data.
Okay,
Yeah.
let me talk later
We'll
on.
talk later.
Yeah,
because,
later on.
yeah.
Okay.
All right. Thank you so much. Wow, that was just the first presentation. So now we move on to the next with Mr. Nazmul Haque, please. Floor is yours.
Yeah. Thank you so much. Good morning, everyone. Yeah. Am I audible, right? I think it's okay. My voice is well enough to go further away. So myself is Mohammad Nazmul Haque, and I'm an assistant professor of urban planning in this country in Kuwait, in Khulna Engineering University. So, and also I'm a mixed doctoral fellow in Hiroshima University in Japan. So today I'm going to talk about some ongoing event in like our countries and also some coastal part of the world that is going to happen every time with some natural phenomena, disaster and something. So just in the first presentation, we already came to know that the disaster mitigation group, we have some vision and mission also, and also ongoing collaboration with different working groups and different open data sharing. So though my study is a simple case study based, for instance, I did the study for the coastal area in our country, that is Deltic region. But I believe do that with this ongoing effort, if I also can actively engage with this disaster mitigation group, and I can also add some value to get some support from the funding agency, I can also add value to implement this model in different large scale implementation in Asia region. So before going forward, if you want to know more about the Bangladesh Delta Plan that is already launched, and there are some policy levels analysis also projected and provided in that plan, that by that time we want to see our Delta region should be more resilient and should be more safe for the people. So what should measures should take from the government side and also from the agency side, all these things as listed in there. But the question is, do the policies still on time for the time we projected or time we wanted to see? So this is a challenging question, and for that question I want to go deeply to see how this is going on in terms of our deltic region in Bangladesh. So as said before, climate change intensifying the vulnerability most often in coastal regions. So because you know that sea level rise and saltwater intrusion, extreme weather events, those phenomena directly hit the people live near the coastal areas. And whenever earthquake happen, you know, the last few months ago in Japan also there is a devastating earthquake, and Japan is a land of earthquake, and every time we feel shaking, and it's common to us, we live in Japan. So also tsunami alert has been provided, and who are affected? The people who live near the coastal areas, and they need to evacuate it. They need to shift their shelter, their living place. So every time there is some risk, there is some emotional values losses, everything is going on with those coastal areas people. So in that sense, what should we can do from the beginning so that the people can live a safe life, that we already have some idea from the previous presentation also back in the Hong Kong meeting. We also get some national level policy analysis, and hopefully today we will also learn more from the policy level analysis on different nations like Taiwan and Thailand and Philippines. They have a well established network and ecosystem to develop some mitigation measures and adaptation measures to cope up with the climate change scenarios in their countries. But in case of our country, what I found that in Ganga Delta region, you know, Bangladesh is crisscrossed by hundreds of rivers and is very close to Bay of Bengal. I will show you the map next on. So we are very prone to the coastal areas, and we have a long belt for coastal region with the sea. And for that, the growing human and environmental pressure is approaching day by day. And the existing assessments, what I found that still lagging behind to map out the physical and also the social factors working behind to identify the vulnerability, to identify the who are actually will be the most affected, and how we can mitigate from these current scenarios in our case. So that's why in my research, I wanted to emphasize three specific tasks. At first, to identify the key physical and social factors. This is some contribution that previously we only think about the physical factors like the infrastructure, the embankment, the shelter, but we also do need to incorporate the social factors, because now we are talking about IoT, we are talking about the smart city, we are talking about the smart governance, we are talking about the open data, big data. But everywhere we implement, this implementation need to be satisfy the people, the more beneficiaries who will be the benefited from this part. So that's why I wanted to also add the social factors in my modeling. And then I also developed a coastal vulnerability model through the GIS-based AHP techniques. AHP is almost very popular, but to integrate in the geographic information system, that is the there is an addition to see how AHP is working on with in addition to the GIS in most specifically this coastal vulnerability model. And then third, I wanted to see the most vulnerable zone and what should be the effective decision to get rid of those scenarios in that areas. Again, this is a very small scale study, and with that study, we can also run for a big like regional level later on. So this is the study area that I told you. The Bay of Bengal is almost touched the lower part of our country, that the southwest part, that the different, I selected different districts that is well known as a coastal region and already suffocated and devastated different problems like seawater intrusion, like the salinity, and whenever cyclone and anything is coming, those people most frequently like receive the bad intention, bad result from the nature than the other side of the country. So we need to emphasize these areas more to see how is things is going on in there. And for the methodological part, I have 3 specific tasks. The first objective is to see the factors, and with the extensive literature review and discussing with the experts, I found 6 set of physical and 4 set of social factors that can be integrated to identify the coastal vulnerability area in those zones in Bangladesh. Again, I need to also acknowledge the limitation of my study because of you know the support mechanism. So I cannot go alone to deep more factors. I need to do the field survey. I need to go to people to learn more. So that is something we need to do by the collaborative way. But with that factors, I also can propose a model that how the vulnerability is making with the physical factors and then with the social. And finally, with the integrated methodological way, I found a vulnerability map where the most affected areas has been designed and mapped. And I also propose some solution measures, how we can go forward to have the area safe, resilient, and for the people. So there are some data sources that is open. So as said again, without open data source nowadays, very tough for us to incorporate the science. For instance, if you ask me, when I'm in Japan, everything, even in Elsevier and Springer Nature, if I want to access any paper, it's very easy for me to get in. But when I come back in our country, it's very sad to say that even we have no access to Web of Science, Scopus databases. This is very unfortunate for the researchers from Global South. This is not case for ours. All the Global South, we are facing the same issues. So that's why I do believe the disaster mitigation group, that is we're working together to have the open data sources and collaborative mechanisms. This will help us for the HA region to do some research and to do a collaborative way. And jump to my result sections, where I wanted to show how the physical vulnerability factors has been defined, for instance, the elevation, slope, the LULC, the land use, land cover, and the geology, because these things makes the area suitability analysis to see which areas is more resistant against the disaster and which areas is less resistance. For instance, the proximity to river. So which area is more close to river? It is supposed to assume that they are more vulnerable whenever any wave and any tsunami is going on. So we provided the weights based on the opinions of experts and the literature to see the model for the physical vulnerability. And also for the social, the population density is very do matter, because sometimes some area is vulnerable, but population density is not so high. So we don't need to think about the population damages in there, the damage of houses in there, because already it is not dangerous for the people because people are not in there. And the ratio to female, because gender is also a burning issue in this aspect, because we know the vulnerability also belongs to some group of peoples. Women is also one of the group in there. We need to provide more spaces on them. Road network, literacy rate. So these four are was the factors I used for social vulnerability, and compiling in AHP with the physical vulnerability classes, I found that most of the areas is high to very high vulnerable based on the physical vulnerability classes. Where in social classes, I found the some areas has a potential based on the social vulnerability classes. For instance, the female ratio, for instance, the economic aspect. So based on that, in AHP algorithm, we all know that this is algorithm counts that we asked the experts, provided the list of the preferences, and then asked them make the ranking be based on your expertise. And this is the scenario of my study, and they made it by their own expertise. And also whether the model is accepted or not, we have to check the consistency ratio. We have to check different simulation based ratio as well to see whether the expert opinions is accepted or not. So after doing the analytical hierarchy process in GIS algorithm in environment, I found that the different regions of the coastal areas, most specifically, you see there's a green zone. It's called Khulna, the name of the district in there. They say they're very low vulnerable against the coastal vulnerability because of the I found that there is a huge belt for mangrove forest that calls Sundarban in our country, and whenever government and said that there is an alarm and we are all praying for safety, and then we feel that oh we're safe because there is a shelter in there. So this is something we need to think about, how we can make our areas not from the man-made perspective, the nature-based solutions as well. To see the validation, I also validate as the ROC curve. It is a well-renowned way to see how the model is fit or not. And I found that the vulnerability model is almost sound okay for this case specific. And I wanted to define that this model is not only for this specific case. If we can make some fine tuning, this model can be adopted in a large scale in different aspects in the world as well. So there's a discussion that sea level rise linked to climate change and high vulnerability zones. As I said, the mangrove forest in the Khulna region, they make the belt to make the area safe and resilient for the coastal people. And for the conclusion, I must say that integrating the AHP with the GIS software, the environment, it should provide us the accurate value than we did in a traditional way. So now the time of the technology, we need to adopt the technology in weather forecasting already. We know about the tsunami warning. Even in Japan, we receive frequent messages that earthquake is coming. So can you imagine it before 30 seconds, before 40 seconds, they send a message in our mobile. Even the call, if you in switched off, if you are mobile, anything, but they are calling you. Please be alert, earthquake is coming. So this is the technological advancement we need to adopt us. We need to precise the location, the coordinate, and also with the help of satellite images and the remote sensing technologies, we can adopt a good, fruitful, and sound policymaker for the coastal areas. Again, come back to my first slide where I showed the Bangladesh Delta Plan, that I found that the existing policies is still not articulated to the target to our coastal areas. It need to be revised, and it's happened to everywhere. You know, IPCC is going on, and recent IPCC's report on the cities and climate change will be launched very soon, after next year. So we are working on that as well as a working group of mine. I'm also working with the IPCC group in there, and I'm also working the climate change scenarios. So I have the capability to do something more with this working group, And I'm looking forward to work more with Dr. Franz and some Eric and Dr. Trinapati from Thailand. I also discussed with him. So if I can also add my value with this group, it will be more happy and glad. I will be more glad to have some contribution in here. Thank you so much for your kind attention.
Thank you, Nazmul. Very impressive work you've done so far, despite the limitations that you've mentioned, especially if we do our work here from the Global South. But anyway, so at this point, let's open the floor. If there are any questions or comments even. Basuki, please.
Okay, thank you. Very nice work. And maybe I'm asking, but did you have some something like a water level sensor in the some area to calibrate with your simulation or your study? Water level sensor,
Yeah.
or is there any water level sensor who accessible to you, and then you can compare with the real with with the real condition in the field?
Yeah, thank you for the great question. So this is something I also acknowledged in my limitation sector, that though this model can be implemented by the ROC curve, where I found the actual soil erosion scenarios from the report, then I validate my result with that. But the question is that from the satellite image, I don't have such data to see how this is going on that. So this is one of the limitation from my from this method, but I can overcome the scenario if there is something I can go forward with that. And I have the idea with that, and thank you for your note. I will do it in my coming time.
Yeah, maybe something like the government have a sensor or something that you can access, and then you can
Yeah.
compare the study. Yeah, thank you.
Yeah. Yeah. So thank you. Yes, I got some idea today, and I took notes, some open source data, and I will go further for that.
Good morning, everyone. Thank you, Dr. Nazmul Haque. I have enjoyed your presentation. And basically, it is not my question. It is my query about the physical vulnerability factors, which you mentioned that some factors are contributing to our coastal vulnerability. But I have noticed that the parameters are not included in any time frame, which time you use. Besides, I have noticed that social vulnerability factor that you have showed, the data are not mentioned in which time you use.
Yeah.
And the query is, if I use different time for the satellite image, for the coastal assessment vulnerability, and for the social vulnerability factors, is there any conflict? Number one question. Social vulnerability are faced at the far away from the coastal region, I have noticed in your presentation. But why? Because most of the people at the nearest of the coast, they face different issues in any hazard. But the map shows that they are the less severe person. But the city people are most severe person in the coastal vulnerability zone. Thank you.
Yeah. Thank you for your insight. Sorry. Thank you for your insightful question. So for the timeline, my intention was not to see the spatio-temporal change. If so, then I could say the time period. But if you show the data sources table, so there has already provided the time which date I took. For instance, for the DEM data is 2014, and the Landsat, the satellite image is 2023. So the LULC is from the Landsat data, and since this is a presentation, I also have the full text. If you're interested, I can also share with you. Still to be published, this work. And for social data, I used the 2011, the BBS, the Bangladesh Bureau of Statistics. But still, there is updated version. So when I did the study, there's the latest one with my hand. I did that. But since this is ongoing, obviously I can update it with the latest version before my submission in there. And for your second question, for the social vulnerability map, that is this one. As you said that whenever in AHP, I shared with that this directly depends on the opinion of the experts, how they define their value and in following the different weights. And I also did the check with the consistency ratio, so that I can do with this AHP modeling. As said before, if I had the enough budget with me, I must go to the field and I can easily see what is going on in there. For instance, in Chuaranga and other areas, I saw there is a red. Do those people all seriously vulnerable or not? If I can go and I can ask the people and see the field level, it would be more acceptable than the modeling in HP. So this is one of the limitation for my expertise as well, because it's the HP based and the limitation is those. And if I can go forward, I will also have some specific data in the field and I can validate it in later on.
All right, thank you, Nazmul. I'm sure there are a lot more questions and discussions for you,
Yeah.
but we are happy that you wish to collaborate more with us in the regions, and we're happy also to connect you with appropriate institutions and experts to move on with your work. Thank you so much. All right, so for now, we move on to the next presenter from the Philippines. So it's a pleasure to have Dr. Teresito Bacolcol, who is the head of the Philippine Institute of Volcanology and Seismology. Sir, the floor is yours.
Good morning. Good morning. Can you see my slide?
Yes, sir.
Okay. So, okay, I'll do okay. So, good morning, everybody. I don't know what time is it now in your place, but here it's almost 12 noon. I'm Teresito Bacolcol, and I'm the director of the Philippine Institute of Volcanology and Seismology. Today, I'll share how the Philippines manages disaster risk from earthquakes, volcanoes, and tsunamis, and how science supports preparedness and decision-making. I'll also point out areas where regional collaboration, particularly through APAN, can further strengthen our efforts. Okay, so to understand why disaster risk reduction is so critical for us, the one with inside that rectangle would be the Philippines, and the Philippines is part of the Pacific Ring of Fire, one of the most seismically and volcanologically active zones in the world. This explains why earthquakes and volcanic eruptions are part of our everyday risk environment. These are not rare events. Right now, we have an ongoing earthquake swarm in the southern part of the Philippines, and since January 19, we've already recorded more than 1,000 earthquakes. So our location makes continuous monitoring and early warning a national necessity. Okay, so with that context, this slide shows what looks like on the ground. Here you can see the distribution of active and potentially active volcanoes together with the major active faults. And this combination is the reason geologic hazards are widespread across the country. Many communities are near volcanoes, faults, or both. These maps would also underscore why we maintain nationally distributed monitoring networks and why risk information must be location specific. And beyond geologic hazards, we also deal with broader multi-hazard environment. The Philippines faces overlapping hazards. Again, we have earthquakes, volcanic eruptions, tsunamis, typhoons, floods, and storm surges. So these hazards can occur in close succession and sometimes trigger cascading impacts. So this is why we promote an integrated multi-hazard approach to disaster reduction. Okay, so given this complex hazard scape, let me now explain the specific role of our institute, which is the Philippine Institute of Volcanology and Seismology. So we call that PHIVOX for short. So PHIVOX is a service institute under the Philippine Department of Science and Technology. with a mandate focused on geologic hazards. We have earthquakes, again, volcanic eruptions, tsunamis, and other related processes. So basically, our primary role is to generate reliable scientific data through monitoring and research, and to translate this into timely warnings, hazard maps, and technical advice. So we work closely with the national agencies. We also work closely with the local government units and communities and private organizations to ensure that this science directly supports preparedness, land use planning, and emergency response. So basically, in essence, FIVOX bridges science and decision-making to reduce disaster risk and save lives. And to carry out that mandate, these are the core technical functions that we at FIVOX perform. So these functions would represent the scientific backbone of our institute. They include national monitoring of volcanoes, earthquakes and tsunamis, hazard and risk assessment, and the management of critical geoscience information. Through these functions, we are able to detect hazard events early, assess their potential impacts, and provide timely evidence-based warnings and advisories. So together, they ensure that science is not only generated, but also delivered in a form that decision makers and communities can act upon. Now, of course, strong technical functions only work if the organization behind them is equally strong. So this slide would highlight the institutional enablers that keep FIVOX effective and sustainable. So we invest in leadership development, strategic human resource management, and performance systems so that we maintain capable teams, especially during prolonged events. We also prioritize ICT development because monitoring, data processing, and rapid information release depend on these reliable systems. So in short, these enablers make sure our science is not only accurate, but also consistently delivered on time, under pressure, and at a national scale. Okay, so all of these efforts point to our ultimate goal, making our communities safe and resilient. So we aim to empower partners, especially the local government units, with accurate forecast, practical tools, and timely information. So the focus is proactive risk reduction down to the community level. To deliver that, we also strengthen our organization itself. We work toward becoming a highly responsive and competent organization. This includes developing experts, sending them outside the country for graduate studies, and strengthening leadership and performance culture. Now, let me make this framework more concrete by showing how each action is actually carried by FIVOX. So these are the key actions for disaster risk reduction which we carry out at FIVOX, at our institute. First, know the hazards and risks. So our institute conducts hazard and risk assessments such as volcanic hazard mapping. We also do active faults mapping and earthquake risk studies for areas like the Metro Manila, because in Metro Manila there's a 100-kilometer long active fault. Again, it transects the whole of Metro Manila, and this fault is expected to generate a magnitude 7.2 event. So okay, we conduct studies here, not only in Metro Manila, but in other parts of the country as well. So this would provide scientific basis for land use planning and preparedness. Second would be monitoring. So we operate national networks of seismic stations, volcano observations, volcano observatories, and tsunami monitoring systems that would allow us to track changes in real time and detect early hazardous activity. Now, the third would be to warn and disseminate the information. So based on monitoring and analysis, we issue earthquake information, volcano bulletins, alert levels, and tsunami advisories, and communicate this through government channels and the media. And finally, respond properly and timely. So during crisis, our institute provides continuous situation updates, technical briefings to decision makers, and scientific guidance to support evacuation, response actions, and public safety decisions. Now, let's move to how we manage specific hazards, starting with volcanoes. So the Philippines has around 300 volcanoes, with 24 classified as active volcanoes. This makes continuous volcano monitoring and preparedness a national priority. And monitoring is complemented by hazard assessment, hazard mapping. So we produce volcanic hazard maps based on historical eruptions, field mapping, geomorphology, and numerical simulations. So these maps would serve as our guide in land use planning, evacuation decisions, and public safety measures. And this work is supported by observatories positioned near priority areas, priority volcanoes. So we operate 7 volcano observatories nationwide. These observatories would provide continuous, real-time data to detect unrest early and support warning decisions. During crisis, we also help in strengthening coordination with the LGUs and national agencies. So basically, that's the role of our volcano observatories. And this slide would show us pictures of our observatories near active volcanoes. So the distribution reflects our archipelagic geography and helps ensure national coverage. It improves situational awareness and supports faster response. Now, shifting to earthquakes, to appreciate the level of exposure in the country, it helps to look at some of the long-term numbers. So on average, we record the red dots that you can see on the slides would be the earthquakes. And as you can see, almost all of the Philippines is peppered with earthquakes. So on average, we record about 30 earthquakes a day across the Philippines, most of which are too small to be felt by people. And each year, around 100 to 150 earthquakes are felt by the public. This would remind us that seismic activity is a regular occurrence. And looking farther back, historical records would show about 100 destructive earthquakes in the past 400 years, highlighting the long-term and recurring nature of earthquake risks. So when we say earthquakes, when we say that earthquakes are frequent, those numbers translate directly into why hazard assessment is very essential. So because again, we record roughly 30 earthquakes a day and still have around 100 to 150 earthquakes felt every year, we need a systematic way to understand where damaging shaking is most likely and how severe it could be. So basically, that is the purpose of earthquake hazard assessment. We produce hazard maps at national down to the local scales, including more detailed mapping in high-risk urban areas. So these maps are used to guide risk-sensitive land use planning, inform engineering and infrastructure design inputs, and support local preparedness and contingency planning. Okay, so risk is not just about hazard, it's also about people and assets exposed to it. So earthquake risk assessment integrates hazard, exposure, and vulnerability. And this is the map of Metro Manila, and Metro Manila has been a major focus, again, due to its population density and the economic as well as the political seat of the country. And all this would rely on a strong monitoring backbone. Our seismic network consists of 129, not 122, as mentioned here. It's 129 station network stations. And this would enable rapid detection and accurate earthquake information for advisories and response. And to ensure reliability, we built a redundancy into the system. So we operate a main data receiving center, and we also have multiple mirror and cluster monitoring stations. So this setup supports continuity of operations even during major events. After detecting a potentially tsunami-genic earthquake, the next critical piece is confirming sea level change and warning coastal communities. So for our sea level monitoring, we currently have real-time tide gauges installed through FIVOX with the JICA support. plus 5 more supported through the partners such as the Pacific Tsunami Warning Center, RIMES, and GLOSS. At the community level, we also implemented 10 community tsunami detection warning systems and deployed 90 community tsunami alerting stations to strengthen last mile alerting. Even with these numbers, there is still a gap remain, and it's quite big. So we still need to set up more sea level stations in different areas to improve confirmation and warning performance nationwide when it comes to tsunamis. And this is where regional cooperation becomes especially important. FIVOX coordinates with international tsunami warning centers such as the PTWC and NWPTAC, tsunami across national boundaries. So timely data sharing and coordination are essential. APAN is a valuable platform for strengthening these regional connections. And monitoring and warnings would only work if people understand what to do. So we conduct education activities through materials, seminars, drills, and media engagements. The objective here is to turn scientific information into practical and easily understandable materials. Okay? So we also sustain outreach beyond single events. We support DRR through regular engagements, public information activities, and partner coordination. This helps maintain readiness during quiet periods. And beyond briefings and advisories, we also make hazard information directly accessible to the public. So a big part of our public communication strategy is the use of digital platforms, which we often describe as information at your fingertips. We develop mobile and web-based apps that would allow users to access real-time earthquake information, hazard maps, and safety guidance anytime and anywhere. By placing by making these apps, these tools can empower individuals, local government units, and institutions to check hazards on their own and make informed decisions even before an event would take place. So by placing science directly in the hands of users, we strengthen preparedness and encourage a culture of risk awareness. While digital tools put information, and this is where regional collaboration matters. So disaster preparedness is not a one-time activity. It requires sustained outreach and long-term partnerships, especially with the grassroots, with the local government units. And we maintain regular trainings, coordination with the local government units, schools, and sectoral partners, and continuous public education to keep risk awareness high even outside crisis periods. So at the regional level, platforms like APAN would allow us to share experience, tools, and lessons learned, helping countries strengthen outreach strategies based on what works in similar risk contexts. Through sustained local engagement and regional knowledge exchange, we move forward toward the common goal of building resilient communities across the Asia Pacific. And that would be all. Maraming salamat. That's maraming salamat means thank you in our language. And again, that would be all.
All right. Thank you, Director Toto. Can you hear us well?
Yes. Loud and clear.
Okay. All right. So let me read some questions here from the chat from Jyoti. I know some of this you've touched on already. First, what is the role of communities in the whole workflow? Second, what is the focus of the communities? And third, are all the observatories in the Philippines or outside too?
All observatories are inside the Philippines because that's where our focus. So, but of course, we get in, data from the global network also. And what is the role of the communities? Basically, the role of the communities is that they are our partners because they receive our information. We work with them, and but at the same time, they are also our partners because they are the recipient of our data, but of course, we train them also on how to act on their own. Like we have community level, we train them, for example, for landslides, how to interpret the data on their own so that they don't need us. For example, if there's rain, the volume of the rain is enough such that it would trigger landslides. They can act on their own.
All right. Thank you, Director Toto. So I'm opening the floor here on site in Dhaka. Are there any questions for Director Toto? Okay, there's a follow-up question in the chat, again by Jyoti. Is the whole network of different components based in the Philippines or outside too?
Yeah, it's the whole of network that we have is based in the Philippines.
All right, thank you. Then last call. Any question or comments? If none, again, we'd like to thank Director Toto. Let's give him a round of applause. Thank you. Salamat po, Director Toto. All right,
Maraming
so
salamat.
from PVOX, we move on to another Philippine agency. May I call on Sir Michael Basa from Pag-asa. Sir, the floor is
Thank you
yours.
very much. Good morning, Sir Franz. Can I share my screen?
Yes, please.
Can you please confirm if you can see my slides?
Yes, sir.
Thank you very much. So again, good morning. My name is Michael S. Bala, and I am from the Philippine Atmospheric, Geophysical, and Astronomical Services Administration. I am currently the Chief of the Research and Development and Training Division. So Pag-asa is actually the National Meteorological and Hydrological Service of the Philippines. And this presentation today highlights, well, I was told to focus more on typhoons, and I would try to put emphasis on how we forecast typhoons and how we disseminate these information to the general public. So a brief overview of my presentation. I will provide a background and context of what Pag-asa does and what our products and services do for the general public. And I will move on to explain science-based disaster risk reduction and also explain an innovation from Pag-asa. Actually, this is something that a lot of meteorological and hydrological services around the world have been moving towards to. It's impact-based forecasting. And then I will touch on how we communicate and disseminate the information to our stakeholders and the general public, and some insights on our plans for the future. Right. So why is disaster risk reduction management critical in the Philippines? Because we are very exposed to natural hazards. In the context of tropical cyclones, we are adjacent to a vastly huge ocean, the Pacific Ocean, and it's fuel is to the engine of tropical cyclones. So it's a very vital part of the development and the genesis of tropical cyclones. In fact, the Philippines is in the path of almost 20 tropical cyclones per year. Almost half of this number makes landfall in the Philippines. So there's also the threat of climate change. Of course, we are beside the Pacific Ocean, and heating of the ocean will cause increased temperatures, and that would contribute to the generation of more tropical cyclones, which conversely will affect the severity of rainfall and the frequency of high impact weather events. And then we also have our communities are very vulnerable to tropical disturbances, atmospheric disturbances, and so this contributes to disaster risk reduction in the Philippines as well. And these hazards, these risks also have a huge impact on economic development. And conversely, we would like to look at it also affects government response and action, not only on budget allocation, resource mobilization, but also on the legislation part and policy making. So because of this, the Philippines put into action the Philippine Disaster Risk Reduction and Management Act of 2010. And PAGASA is actually a part of disaster prevention and mitigation and disaster preparedness. So the purpose of the act is to strengthen the Philippines disaster management system by shifting the focus from disaster response to disaster risk reduction and management, and emphasizing prevention, preparedness, mitigation, and resilience. So from the four pillars of the thematic pillars of the act, the first two actually is where PAGASA is contributing. So this is the mandate of PAGASA, simplified into a schematic. So we actually have three operational processes that provide to the left of the diagram is forecast guidance, which is shared to the general public as a pre-event product. It's supposed to be actionable such that the public can prepare themselves for impending hazards. Also, to the right of the diagram are science and technology-based assessments. So you can think of this as for long-term planning, for climate change adaptation strategies and other mitigation measures that local government units or the national government can adapt, such that when high impact weather events occur, they will be prepared and the impacts may be mitigated. And lastly, we also issue observed data. These observed data are from our network of observations, measurements and instruments. Some are meteorological, some hydrological, also some are astronomical. What you can see in the image, central to our function or our mandate are our observations. And we would like to focus on how we communicate and how we disseminate this information to the general public and our stakeholders. So it's highlighted in the diagram, the red arrow. So everything that we do in PAGASA is intended to inform the general public and our stakeholders. So if we go back to the three operational processes, the most important in these three processes is probably the first one, because during high impact weather events, when science-based time-sensitive information is key, we have to provide actionable information to the general public. So we would like to think of it as a four-stage loop of observe, interpret, decide, and communicate. For the first stage, observe, we want to continuously monitor the hazards, atmospheric systems or the atmospheric disturbances, and meteorological and hydrological parameters. And these can be on the ground observations like our synoptic stations. We also have remotely sensed instruments like radar, and we have satellite feeds from satellites all over the world. Our partners and other weather services. And we also have water level stations and gauges all around the Philippines. So each of these observations we try to interpret using numerical and conceptual models. So currently we are using WRF as a research model, but we also have an operational WRF system in place. We also receive model data, model output from the ECMWF and the unified model from the United Kingdom Met Office. But we are trying to also explore operationalizing AI models. So we currently have a project with ASTI actually, and we're trying to explore a US-based AI model. But here in PAGASA, we are also exploring the open source AI models, and we're trying to verify their output according to high impact weather events their performance during high impact weather events. And hopefully within the next 2 years, we can operationalize 1 or 2 AI models. And then the next stage would be the decide stage. This is where formulation of forecast guidance is done. So we synthesize all of the interpretations from all of the models available to us, all of the data and information available to us. So we try to finalize the forecast guidance, which is intended for integration into DRR operations. So lastly, the hazard information from the design stage from our products and services tend to be very technical. So we try to simplify or translate some of the hazard warnings or advisories into actionable information. So we also understand that there's a little difficulty in understanding our technical forecasts or our technical information. So this is something that we do, and we try to explain to the general public and to our stakeholders in terms that are easier to understand. But of course, it's always a challenge in doing that. And there are other strategic functions or strategic activities being undertaken by PAGASA to at least raise the level of awareness and understanding of our stakeholders. So this is our observation and monitoring network system. It's an end-to-end early warning system. So we start with the observations and we integrate and process or analyze the current situation of the atmosphere. And then we try to create the forecasts. We try to disseminate advisories and warnings. And then we utilize communication platforms. So it used to be exclusively via the media and the local government units. But of course, with the advent of technology, we've also utilized the social media platforms and mobile applications in doing the dissemination of information. And then so after disseminating this, the outcome that we're trying to get is a response from the general public and from our stakeholders. So in trying to communicate or disseminate this information, we participate in pre-disaster risk assessment, some on the national level and also some on the LGU level. So we have regional services divisions scattered all over the Philippines. We have 5 actually. We have 1 in the north and 1 in the National Capital Region, 1 in Southern Luzon, 1 in Visayas, and 1 in Mindanao. And on the national level, it's actually a collaboration between the Department of National Defense and the Department of Interior and Local Government and the Department of Science and Technology. So the role of PAGASA in the PIDRA is to provide weather or flood forecasts, issue typhoon, rainfall, and flood and storm surge advisories, deliver impact-based guidance to identify risk areas, support risk analysis and alert level setting, and strengthen early warning and preparedness actions. So these are snapshots of the PIDRA at the national level. So this is done in the Office of Civil Defense. So we have in attendance here the Secretary of Interior and Local Government and the Secretary of Science and Technology. And on the background, we have members of PAGASA that try to provide guidance such that the PIDRA, the members of the PIDRA are informed and they can communicate it to the local government units what actions they have to take. And sometimes there's one realization that I've had throughout the course of these meetings, and sometimes PAGASA, as a national weather service, we try to provide the most likely scenario. However, for disaster risk reduction, they always want they want the worst case scenario. So PAGASA just has to provide these types of information for them to have basis for their decisions. This is one innovation. I'm saying it's an innovation because we haven't operationalized it for the entire Philippines. We still are working on some pilot areas. and it's impact-based forecasting. So it's a paradigm shift from what the weather will be to what the weather will do. So previously, we used to provide hazard information about tropical cyclones, typhoons, where the typhoon will be, what the track will be, how strong the typhoon will be, how much rain will it give over its passage in the Philippines. But we also have we've tried to transform this information into something more actionable. So instead of just giving technical terms about wind speed and rainfall intensities, we also want to communicate to our stakeholders what the impacts will be on the ground. So instead of giving amount of rain, we want to say how much flooding it will give, or how much for each of the sectors of society. For example, for agriculture, for health, we have different impact tables for each of the sectors, and we want to try to disseminate or to translate the hazard information to the impacts that they will experience from those hazards. So this is a schematic of the impact based on how we develop impact tables from the multi-hazard impact-based forecasting and early warning system project. So first, we engage with our stakeholders from the local government units, and we have an introductory meeting regarding impact-based forecasting and early warning. And then we have an intermediate sectoral focus group discussion, and we work on the impact tables. So we identified hazards as to floods, severe winds, storm surges, and landslides. So the last stage of the creation of the impact tables is the thresholding and risk calculation. So we have impact tables for each of the hazards that I mentioned, or at least it's currently under development. To augment our observation network, we also have a storm chasers group. Our storm chasers group actually go to the exact location of the landfalling tropical cyclones. So these are in situ observations. The idea is to take in situ observations because we have a limited observation network in the Philippines, and the density of these observations are not really dense. So we try to augment that with in situ observations, and our storm chasers travel to where the tropical cyclones are forecast to make landfall. And we set up instruments, we measure and record this meteorological parameters. And in real time, we send this data to the forecasting section of Pagasa, so they can monitor and verify in real time the forecast that they did prior. And so we also, after passage of the tropical cyclone, we also do field assessments. So we try to look at the area and look for and try to characterize the impacts with regards to flood, with regards to severe wind and storm surges. So this is the communication and dissemination flow, especially during high impact weather events. So Pag-asa provides information to the Office of the President, to the National Disaster Risk Reduction Management Council, or the Office of Civil Defense. We also send to our Pag-asa regional centers, and of course the national media. So it's usually the conduits are usually the local government units and the national media before it reaches the general public. So they are our very important partners in disseminating hazard information and impact information, impact forecasts for especially during tropical cyclone passage. So as I've mentioned earlier, these are our communication channels. We still use telephones and fax machines, but we've also tapped social media platforms and mobile applications in doing the dissemination work. So we regularly conduct press conferences and briefings and interviews during tropical cyclone passage or typhoons. And we engage with our stakeholders in social media and other digital platforms. Of course, we also go down to the LGUs, the local government units, down to the barangay levels and local DRR offices. Aside from operational functions, we also have strategic functions, which are our information and education campaigns. And we try to conduct drills for students and local government units to prepare them for floods, for typhoons, and other pag-asa-related hazards. So we also get feedback from local observations and reports and social media comments. So this is an example of some drills that we conduct for improvement of public understanding of warnings and alert levels, which reinforces preparedness and early action at the community level. So for our way forward, since I am from the research and development team, for the first stage, we would like to ask the science, we would like to ask the questions, how do we improve our observations? Can we develop new tools or technology or modernized methods? So currently we have a few project proposals that we drafted that are awaiting for approval. So we want to tap social media because social media is home to a lot of pictures and videos and reports, anecdotal reports from on the ground from the general public, and we are trying to get those. We are trying to provide a community-based reporting platform so that we can capture all of these observations from the ground, from Twitter, from Facebook, and other social media platforms. We also so proposed to build a prototype of an covariance system which can help our numerical models to represent the atmospheric environment and the atmospheric disturbances. For the interpret stage, as I've mentioned earlier, we have a few activities with regards to AI. We're still evaluating dynamic or deterministic models, but we also want to transition to AI models as well. And also on the communicate stage, we want to test out new methodologies, or we want to establish key performance indices on how to engage with the general public, especially using social media platform. But it's one of our areas of focus, science communication. We want to focus on science communication moving forward. All right, so that's the end of my presentation. Thank you very much.
All right. Thank you, Sir Michael. So now we open the floor for any questions or comments.
Hello, my name is Vishal. I'm from Nepal. You mentioned about the role of Pagasa in pre-disaster risk management. So what can be the tools and techniques that can be used for this purpose, or what are being used for that one?
Can you repeat that last part?
What tools and techniques are being used for pre-disaster risk management in the Philippines?
So I think the most important thing with pre-disaster risk assessments or presentations to non-technical personnel, meaning non-meteorologists, is to simplify the technical terms. So this is where science communication really is emphasized. So you have to focus on simplifying your language when you're conversing with the disaster risk reduction managers, especially on the national level. They don't speak your language. They don't speak technical language. So it would be really handy if you already learned how to communicate the technical information to non-technical personnel. And also your maps, the maps that you have for operational use sometimes won't work with non-technical personnel. So your maps should be really intuitive. They should be really, so the intention is for it to be actionable. So they won't have you all the time to explain the maps. So sometimes you have to simplify your maps as well. So if you can use, so color itself, if you heard about psychology of colors, you can also use that because each color may give a different impression. So of course, sometimes when we see red, yeah, that's alert status or evacuation status. That's danger status. So you have to just apply science communication strategies to your products and services, because sometimes these maps will represent your technical information, but sometimes you won't be there to explain them. So yeah.
Thank you, Sir Michael. One last question from the floor. If there's any. There, Husni from Indonesia.
Yes, thank you very much. This is Husni from Soy Asia. I'd like to ask about the international collaboration, especially in the Southeast Asia, because I understand it, Philippines is the most vigilant in terms of the cyclones, and then recently we had this Senyar that affected southern Thai, Malaysia, and as well as Indonesia. If you kindly elaborate the international collaborations led by Pagasa on this watch, because as an Indonesian, even though I don't live in Indonesia, the way I understand it is we only saw news or science communications coming from X by someone from that watches the Western Pacific tropical storm. So if you care to elaborate your international collaboration on this one, thank you very much.
Yeah, thank you for the question. Of course, we're part of the Typhoon Committee. We're a member of the Typhoon Committee. And I think, if I'm not mistaken, Malaysia and Indonesia are also part of the Typhoon Committee. But for research projects, for innovations, we have partnerships with Taiwan, we have partnerships with Korea and Japan that are centered on not only on forecasting or modeling tropical cyclones, but also dissemination or communication of the hazards and impacts of these tropical cyclones. We also have a partnership with the UK Met Office, which I think Indonesia is also a part of. It's a weather and climate for services, sciences for service partnership. And yeah, I think that would be it for research collaborations. So it's Japan, Taiwan, Hong Kong, and the Typhoon Committee. Yeah, the UK and the US. So for Hong Kong, we're working on nowcasting, and nowcasting of tropical cyclones is also part of it.
All right. Thank you, Sir Michael. So let's give him a round of applause, please.
Thank you.
So great session so far. This concludes the first session. So now we're moving to our tea break. So let's resume at 11 a.m. Dhaka time. Thank you. Thank you.